They said these aircraft were impossible. Too weird, too risky, too dangerous to fly, but they took off anyway. From Cold War rotorcraft to futuristic tilt rotors, you're about to see aviation ideas so crazy. They actually worked. Stay with us. What you're about to discover will change how you see flight forever. Built in 1947, the Kellett XR-10 was a large American helicopter designed to carry 10 passengers plus 2 crew. Its most unusual feature was a dual intermeshing rotor system that eliminated the need for a tail rotor. While this approach promised greater control and compactness, it introduced serious mechanical risks. The aircraft's frame looked improvised, but its ambition to redefine rotorcraft layout was undeniable. Two Continental R 975-15 radial engines, each producing 425 horsepower, gave the XR-10 a top speed of 120 miles per hour and a range of 362 miles. It could lift up to 1,100 pounds of cargo. However, keeping both rotors perfectly synchronized was critical. Any mismatch could be catastrophic. The margin for error was razor thin. During testing, the system's danger became clear. The rotors collided mid-flight, prompting design changes. But on October 3, 1949, test pilot Dave Driscoll was killed in a crash, ending the program. A planned civil version with seating for 16 never left the drawing board. What seemed like a breakthrough proved too unstable to trust, showing that innovation must always be balanced with safety. Despite its flaws, the Kellett XR-10 remains one of aviation's boldest missteps. It was more than a machine. It was an airborne laboratory that pushed rotorcraft design to its limits. By trying to reinvent heavy-lift flight, it showed that unconventional thinking can drive progress or lead to failure. That fine line between genius and danger defines the legacy of this daring experimental craft. In 1923, Spanish engineer Juan de la Cierva created one of aviation's strangest concepts, the autogyro. With a free-spinning rotor like a windmill on top and no engine connection, it generated lift using only airflow. Light, odd-looking, and mechanically daring, it challenged the fundamentals of flight and marked the first serious step toward rotorcraft innovation. Early models were unstable and prone to tipping due to uneven lift distribution. De la Cierva solved this by introducing flapping hinges, which allowed rotor blades to move independently. What started as a dangerous curiosity began to show promise, pushing aviation engineers to rethink what flight dynamics could be. The autogyro's wild concept slowly turned into a credible flying machine. Its main rotor spun freely at around 130 revolutions per minute, while the forward engine powered a conventional propeller. Lift came from centrifugal force, but mechanical failures and structural issues led to several accidents. Engineers had to rethink safety and refine design elements, eventually boosting performance and proving the aircraft could operate beyond the test bench. Before takeoff, the rotor had to be pre-spun mechanically, only then sustaining itself in flight. This blend of simplicity and originality turned the autogyro into a symbol of radical thinking. Once seen as a flying oddity, it paved the way for today's helicopters. And speaking of extreme designs, our next aircraft was so massive and strange, many doubted it would ever get off the ground. Built in Germany in 1942, the Messerschmitt Me 323 Gigant was one of the largest military transport aircraft ever flown. Originally a glider, it evolved into a 6-engine monster built to haul tanks, ammunition, and troops to the front. With 26,400 pounds of payload and rocket-assisted takeoff, it defied both engineering norms and physics itself. Its structure combined steel tubes, wood spars, and fabric skin. Reinforced plywood wings made it look almost handcrafted, yet it worked. First intended for a failed invasion of Britain, it was repurposed for use on the Eastern Front. The cockpit housed 7 crew members, including in-flight engineers. Despite its improvised feel, it proved that unconventional designs could achieve real results under pressure. With a top speed of only 118 knots, the Gigant was slow and extremely vulnerable, requiring constant fighter escort. But its cargo capacity was unmatched, carrying tanks, vehicles, artillery, or up to 130 soldiers. 3 engines turned clockwise, 3 counterclockwise, preventing torque issues. Early wooden propellers were later replaced with stronger metal versions. Armed with 6 MG-131 machine guns, it offered basic defense while pushing logistical limits. The ME-323 became a symbol of high-risk, high-reward aviation in wartime. Odd-looking and brutally functional, it reflected the urgency and raw innovation of World War II. And it wouldn't be the last time engineers threw caution aside in pursuit of lift under fire. Developed in West Germany in 1967, the Dornier Do 31 became the first and only jet-powered vertical takeoff cargo aircraft ever built. Designed to operate from highways and remote zones, it was meant to keep air operations alive in the face of crisis. Though the idea seemed extreme, it aimed to fuse helicopter flexibility with jet-powered lift and speed, a bold leap in Cold War aerospace logic. The aircraft featured 2 Bristol Pegasus 52 engines with 15,500 pounds of thrust each, plus 8 Rolls-Royce RB162 4-Delta engines, each producing 4,400 pounds. With 16 exhaust outlets and immense thermal load, it faced constant heat and balance issues. It flew up to 400 miles per hour and had a range of 1,100 miles when fully loaded. Three prototypes were built: the E1 for conventional flight, E2 for static testing, and E3 for full vertical transitions. The E3 succeeded in switching from vertical to horizontal flight and debuted at the 1969 Paris Air Show, setting world records. Still, the surplus of engines created weight issues and limited payload capacity, crippling its operational potential before it could deploy. The program was canceled in April 1970 due to high costs, lack of international interest, and technical complexity. Proposals like the Do-131 and Do-231 never advanced. Yet the Dornier Do 31 remains one of the boldest feats of aviation engineering, a wild but almost viable idea that showed how far vision can fly before gravity takes over. Built in 1947 by Howard Hughes, the Spruce Goose was America's colossal response to wartime submarine threats. Designed to carry tanks and troops across oceans, its full wooden construction raised eyebrows in both Congress and engineering circles. At over 200 feet wide, many thought it too fragile, too strange, and too expensive to ever get off the ground. Its development began in 1942, but suffered from endless delays, detailed redesigns, and Hughes's perfectionism. By the time the war neared its end, most saw the aircraft as a personal obsession rather than a military solution. Yet Hughes pushed forward. Despite the doubts, the technical ambition behind the Spruce Goose had no equal among cargo aircraft of the time. Construction became a public spectacle. Giant wooden sections were moved through Long Beach streets with cranes and cable removals. The aircraft weighed over 300,000 pounds, pushing engineering limits with every bolt. Its assembly wasn't just complex, it became controversial. With the U.S. Senate questioning its cost and calling it a dangerous misuse of national resources. But in 1947, Hughes stunned critics by flying it for 1,600 feet at 70 miles per hour. It never flew again, but that short hop secured its place in history. The Spruce Goose remains one of aviation's most daring achievements. It proved that even improbable ideas, when built with enough vision, can lift off, even if only once. Built in Australia in 1952, the Jindivik was one of aviation's strangest creations. It was made to be destroyed. Named from an Aboriginal word meaning the hunted, it served as an unmanned target drone for guided missile testing. Launched by trolley and guided remotely, it pushed technological limits in an era when the concept of pilotless flight still seemed borderline science fiction. Each mission demanded extreme precision. From launch to remote telemetry, the process had no room for error. A single malfunction could result in loss of control, so engineers installed an emergency self-destruct system to prevent crashes in populated areas. It was a brutal, yet effective solution. If something went wrong, the aircraft would vaporize mid-air to keep the operation secure. Despite its simple appearance, the Jindovic required advanced tech for its time. With a conventional turbojet and analog flight control, it needed a dedicated airstrip, hydraulic skid for landings, and highly trained support crews. Flights were costly and depended heavily on weather. One bad signal or timing mistake could compromise the mission. Every flight was a high-risk ballet of logistics and technology. As drone tech evolved, the Jindovic became obsolete. Modern UAVs are lighter, smarter, and far more autonomous. In comparison, the Jindovic began to look outdated and overly complex. Yet it remains a bold reminder of an era when flight was about testing boundaries, and the tools were built to be expendable. And the next aircraft on our list continued this tradition with pure logistical madness. The Hiller YH-32 Hornet, introduced in the United States in 1955, was a lightweight, radical helicopter built around one of the strangest propulsion concepts ever tested. Two ramjet engines were mounted at the tips of the rotor blades, eliminating the need for a tail rotor. This reduced mechanical complexity and created direct thrust at the source, but also introduced wild aerodynamic and operational risks. Each ramjet weighed just 13 pounds and produced 45 horsepower. With both engines active, the Hornet delivered 90 horsepower directly to the spinning blades. The concept was bold, but flawed. Ramjets are designed for supersonic speeds, not the slow rotation of helicopter blades. As a result, fuel burn was massive, range was poor, and noise levels were so extreme that night testing lit up the skies. Safety was its Achilles heel. If one ramjet failed, autorotation, crucial in emergencies, became almost impossible. The drag from the dead nacelle would destabilize the descent. Even so, the Hornet could carry modest loads and was evaluated with light weapons. The YH-32 Alpha variant featured a streamlined cockpit and armament mounts, but performance still fell far short of real combat needs. Though it never reached mass production, the Hiller YH-32 Hornet is remembered as one of the most eccentric helicopters in aviation history. Its promise of simplicity collided with brutal engineering realities, but it also proved a timeless truth. Pushing limits often means courting failure, and sometimes the strangest ideas are the ones that push aerospace science forward, whether they fly or not. Introduced in 1924, the Fokker F-7 marked a breakthrough in early commercial aviation. It evolved from a single-engine version into the famous tri-motor F-7/3M, offering greater range and safety for international routes. Used by carriers like KLM, it became one of the most trusted aircraft of its era. Despite its homemade look, it made passenger flight practical when civil aviation was still filled with uncertainty. Its fuselage combined steel tubing with fabric, and its wings were made of plywood-covered wood. This lightweight design allowed landings on rough airstrips. Equipped with 3 Wright J5 Whirlwind engines producing 220 horsepower each, it reached speeds of 92 knots and flew up to 680 nautical miles. It carried 8 to 12 passengers plus 2 crew, proving that function often outweighed appearance. Passenger comfort was minimal. Entry was via external steps. Seats were made of wicker. There was no cabin pressurization, just noise and freezing temperatures. Still, it was considered dependable. Even without luxury, the F-7 delivered safe flights when standards were evolving. Flight attendants balanced coffee trays mid-air, a chaotic scene that defined early airline service and aviation's improvisational beginnings. The Fokker F-7 left a legendary legacy. Richard E. Byrd flew one over the North Pole in 1926. Amelia Earhart crossed the Atlantic and won in 1928. Charles Kingsford Smith flew his across the Pacific in the Southern Cross. These achievements made the F-7 an icon of aviation daring, built with basic materials but capable of extraordinary milestones. Unveiled in Britain in the early 1950s, the Bristol Brabazon was one of the largest aircraft ever built at the time. Measuring 177 feet long with a wingspan of 230 feet, it dwarfed even the later Boeing 747. Designed with private suites, a lounge, a bar, and even a 23-seat cinema, it turned air travel into a luxurious airborne cruise ship. Behind its elegance were massive engineering challenges. The Brabazon used 8 Bristol Centaurus radial engines with counter-rotating propellers and highly complex gearboxes. Weighing over 280,000 pounds, it needed lightweight materials and refined aerodynamics just to take off. It cruised at 217 knots with a range of 5,500 miles, but required a large, specialized crew. Released during a global aviation shift, the Brabazon struggled to stay relevant. While the public was amazed by its size and comfort, airlines demanded smaller, more economical planes. Even BOAC, which co-developed the project, declined to adopt it. The world was moving toward jet propulsion, and the Brabazon's slow, grand concept felt outdated before it ever saw service. Cancelled in 1953 after costing over £6 million, the Brabazon never entered production. A larger second version with turboprops was never completed. Just 9 months later, Boeing unveiled the Dash 80, which became the 707. The Bristol Brabazon remains a warning of how even the grandest designs can miss their moment. Ambitious, beautiful, but grounded by timing. Created in Canada in 1965, the Canadair CL-84 Dynavert was one of the earliest tilt-wing aircraft to seriously challenge conventional flight logic. Designed to combine helicopter agility with airplane speed, it began as a risky concept in 1954 and evolved over a decade into a radical VTOL prototype. It was bold, futuristic, and aimed at operations in remote and unprepared regions. The Dynavert's structure posed constant engineering challenges. With tilting wings that rotated 90 degrees and an automatic hybrid control system, it transitioned between vertical and horizontal flight with surprising fluidity. Powered by 2 Lycoming T-53 engines producing 1,400 horsepower each, it reached speeds up to 287 knots, outperforming many helicopters. Test pilots praised the CL-84 for its stability and precise handling, yet its complexity remained a threat. Four prototypes were built, and 2 suffered crashes, both without casualties. These failures revealed the thin line between innovation and risk. The aircraft's flight characteristics were ahead of their time, but many considered the project too wild and mechanically fragile for practical deployment. Despite its superior capabilities, the Dynavert was never mass-produced. Political barriers, lack of funding, and resistance from foreign defense markets shut it down. The program was officially cancelled in 1974. Still, the Canadair CL-84 remains one of Canada's most ambitious aerospace efforts, a rare symbol of radical creativity, technical audacity, and visionary aviation that flew ahead of its time. Introduced in Britain in 1950, the Blackburn Beverley was one of the most rugged transport aircraft ever flown. Designed to carry 2 trucks, 2 trailers, and dozens of passengers, its sheer size defied all norms. Although functional, its enormous boxy shape gave it a bizarre look that required meticulous planning and constant risk assessment just to keep it in operation. Preparing the aircraft was physically demanding and highly technical. Ground crews climbed internal and external ladders to check critical components and massive radial engines. Refueling and pre-flight checks had to be perfectly synchronized. Its size created access problems, and its extreme weight made takeoffs and landings on rough strips a nerve-wracking process, even for seasoned crews. During airdrops and troop deployments, the Beverley demanded absolute precision. Any delay in door release, altitude misjudgment, or cargo shift could cause disaster. Its high center of gravity and slow speed made it vulnerable to crosswinds. Still, it operated in conditions where few dared fly. It became a flying solution for missions that prioritized load capacity over elegance or ease. Eventually replaced by more modern designs, the Beverley retired but left behind a technical legacy. Its massive frame and versatile use are still remembered as wild ideas that actually worked. Taking off in such risky conditions proved that innovation sometimes ignores elegance. The Blackburn Beverly stood as proof that if a problem was big enough, the solution could be even bigger. Launched in 1947, the Boeing 377 Stratocruiser was one of the most luxurious airliners ever built. Featuring a pressurized cabin, air conditioning, and a lower deck lounge, it offered a level of comfort that seemed absurd for its time. Derived from military platforms like the B-29, it merged long-range capability with unmatched elegance in a body that looked too oversized for commercial standards. Powered by four Pratt & Whitney R4360 Wasp major radial engines, each producing 3,500 horsepower, it reached cruise speeds of 300 miles per hour and could fly over 4,600 miles. Weighing 150,000 pounds at takeoff, it burned more than 3,000 gallons per trip. Brilliant on paper, but demanding in the air, its sheer size and complexity tested the limits of available technology. Despite its promise, the Stratocruiser came with serious risks. Engine failures, runaway propellers, and unstable pitch systems led to fatal crashes. Between 1951 and 1970, 13 hull-loss accidents resulted in 139 deaths. Behind the lavish interiors lay mechanical volatility. Flying it wasn't just a luxury, it was a gamble between comfort and catastrophe. By 1950, production had ended, with only 56 aircraft delivered. The arrival of jetliners like the Boeing 707 made it obsolete. Still, the Stratocruiser remains an icon, proof that innovation can both soar and stumble. Its blend of luxury and experimental engineering gave rise to a new standard, even if the dream was short-lived. And yet, aviation dared to push further into even stranger skies. These rare inventions weren't just about flying, they redefined what flight could be. Some changed military aviation forever, others became forgotten prototypes, but all helped shape the future of aircraft technology. Hit the like button if any of this blew your mind. It helps us keep bringing you this kind of high-impact aerospace content. Subscribe right now for more futuristic helicopters, vertical lift experiments, and forgotten aviation legends. Leave a comment and tell us which idea you thought was the wildest. And share this video with a fellow aircraft nerd. It'll make their day. Watch the videos that appear here on the screen and stick with us. Bye-bye.